Hello everyone, I'm just like stalling at this point because this is another single problem video. And that is because I'm running low on problem storage. Anyways, today we're looking at the Amy problem 13 of 1983, and it is this problem. So we have, for any set that contains the integers from 1 to n, each its non-empty subsets has a unique alternating sum. And it is defined as arranging the numbers in the subset in decreasing order and then beginning with the largest, add and subtract, and yeah, you can just read the following by yourself. And now we're trying to find the sum of all such alternating sum for n equals 7. So you can pause the video and think about it yourself. I think this is actually a more interesting one because especially for us coders, which I assume if you're watching this video, you're probably more of a coder than a math person. But yeah, so for us coders, I think it's a bit more interesting. Okay, so let's take a look. First of all, notice that just the phrase subset itself reminds us of binary because that's how subsets are usually chosen. And notice that for every element, there's exactly 1/2 chance it's chosen in each subset, which means since it's 7, so out of the 2 to the 7 subsets, each element is in 2 to the 6 of those subsets. And we also notice that the parity of the element, like whether it's plus or minus of the element, the sign of the element is completely determined by how many elements is chosen in front of it. And if we just play around with a few of them, say let's take a look at 6, notice that there is 1/2 chance that 7 is in the set that this set that 6 is in, and there's another 1/2 chance that 7 is not in this set that 6 is in. So there is exactly 1/2 chance for 6 to have a positive sign and another 1/2 chance for 6 to have a negative sign in each of the sets that it is in, which means that all the values of 6 in all of the subsets cancel out. And the same applies for 5, because when there's both 7 and 6, 5 is positive. When there's only 7 or only 6, 5 is negative. And when there's neither 7 nor 6, 5 is positive. And notice there's 2 cases for 7 or 6. There's one case for neither, and then one case for both, which means that out of the 4 possible cases, half of them give 5 positive negative sign, and half of them give 5 positive sign. Wait, no, half of them, these two gives 5 a positive sign, and these two gives 5 a negative sign. And we kind of realize the same pattern for every single other number other than 7, which whenever 7 appears is positive, which means that every single element will cancel out except for 7 itself. So the sum is just the number of occurrences that 7 appeared, which is just 2 to the 6th of the sets, times 7. And if you have noticed, 6, 7, yeah. And the answer is just, what is 2 to the 6th power? 64 times 7. That is going to give us 448, I believe. Okay. So yeah, I would say this is one of those more interesting problems because it's closely tied with binary and coding. So yeah, I was able to solve this by myself, which was quite... No, actually, did I? No, I thought it was 0 because I was dumb and I thought 7. I didn't think of 7. I thought it was just the same for everyone, but I guess not. Anyways, thank you for watching, and I haven't been doing a lot of math. See you tomorrow.